All right, so let's take a look at some examples here. So these are just miscellaneous examples, and I wrote all the properties that we've learned on the side here, right? So we have the product property in order, quotient property, or quotient rule, product rule. So product rule, quotient rule, power of another power rule, right? Which I just call the power rule. Then we have power of a product, power of a quotient, anything to the first power is itself, right? Or anything by itself has an exponent of 1, right? And then anything to the 0 power is 1. So we'll use all these different properties within these this set of examples here. So number 62, there's a couple ways we can do 62. For the sake of time, I think probably the most straightforward is probably to evaluate each exponential expression first and then multiply, right? And basically just follow order of operations. You could also use the power of a product rule backwards and condense those into one product to the third power, but I think this way is a little more straightforward. So 10 cubed, I'm going to evaluate that. That would be 1,000. I'll show you a trick with 10 powers of 10 in class. All right, and then 3 cubed is 27. So 1,000 times 27 is 27,000. All right, number 64. So here we have 2 cubed times 2 to the 4th, same thing. 2 cubed, or well, you could evaluate these just like we did, right? 2 to the cube, or 2 to the third power is 8, 2 to the 4th is 16, then you can multiply those together. Or you can use the product rule, since we have like bases, right? We can add the exponents. When we multiply the bases, we can add the exponents. So 3 plus 4 is 7. And 2 to the 7th power is 128. Okay. Now we didn't have that option with 62 because 10 and 3 are not like bases. All right, 66. I could distribute this 2 into the inside exponents, use the power of a quotient rule, or we could use the quotient rule inside first, since we have like bases of 3 and 3, and then apply the 2. So I'm going to do it that way. So I'm going to remember there's an invisible 1 right here. So I'm going to subtract the exponents. 3 minus 1 is 2. Okay, and then I have a 2 on the outside there. So 3 squared to the 2nd power. Now I can use the power rule, right? This one. This one here. So I multiply the exponents. So I end up with 3 to the 4th. And actually that's not simplified, right? 3 to the 4th can be simplified to 81. So don't ever do what I was about to do and leave numbers with exponents, right? Make sure you always simplify those. All right, 68. Here we have product rule, right? X to the 5th times x to the 8th. We can add the exponents. 5 plus 8 is 13. Can't simplify that, right? All right, 70 we can do a couple different ways. My suggestion is anytime you see anything to the 0 power, cross that out and turn it into a 1, right? So a to the 0 is 1. Anything to the 0 power is 1, right? And so a to the 9th times 1 is just a to the 9th. You could also use the product rule there and add 9 plus 0, and that would also give you a to the 9th, right? Now 72, we're adding the a and the b, right? We're adding the a to the 0 plus b to the 0. So we don't have, none of these properties involve adding bases, right? So so here we're going to use our 0 exponent rule. So anything to 0 power is 1. So we end up with 1 plus 1, which, anybody? That's right, that's 2. All right, 74. And remember, you can pause if I'm going too fast. I definitely don't want to belabor these, but if you need extra time, pause it and maybe run it back and listen to it again if you need to. Okay. All right, so here, b to the 5th to the 8th power, this is the power rule. So we can multiply those exponents together. So we get b to the 40th. All right, 76, here we have power of a product, right? So we have that going on. And so there's nothing I can do inside the parentheses. So what I'm going to do is distribute the outside exponent to the inside exponents. So I'm going to have an x and a t. The exponents will change. 6 multiplied by 2 is 12. And 4 multiplied by 6 is 24. So we get x to the 12th, t to the 24th, and that's our final answer there. All right, 78. Dividing two exponential expressions, the bases are the same, so we can use the quotient rule, right? So I'm going to get one single m. I'm going to subtract the exponents. 10 minus 8 is 2. All right. And number 80, nothing to do inside the parentheses, so there's nothing to simplify there, so we're going to use the power of a quotient rule and distribute. We have to remember there's an invisible 1 there with the t. So we're going to have a t on top, m on the bottom, but the exponents will change. 1 multiplied by 4 is 4, and 4 multiplied by 2, 2 multiplied by 4 is 8. Can't simplify that. All right, and last but not least, we have number 82. So here we have a few different rules going on. So first of all, let me just hopefully squash your misconception. So a lot of times people overgeneralize, right? Sometimes you see the 4 on the outside and we know we're going to distribute, right? We're going to multiply 4 by 3, 4 by 2. And sometimes people try to multiply the exponent times the number, right? Some people might say, oh, well, 4 multiplied by negative 2 is negative 8, right? But that's not the case. Remember, we're not multiplying with our power of a product rule. We're not multiplying n times a. We're multiplying n times the exponent of a, right? So going back to this, we're not multiplying 4 by negative 2. We're multiplying 4 by the exponent of negative 2, which is a 1, right? Okay, so anyway, watch out for that. So we have negative 2, that's our base. We're multiplying 4 by the exponent of that. So 4 times 1 is 4. Okay, then we bring down the x and the y. 4 times 2 is 8. And 4 times 3 is 12. All right, and then we can simplify that. 2 to the 4th, negative 2 to the 4th is going to be positive 16. And remember, if you multiply, if you have a product of an even number of negatives, you'll end up with a positive, right? If this exponent was odd, we'd have a product of an odd number of negatives, and our result would be negative. So even exponent, you'll always end up with a positive, right, when you're dealing with real numbers. All right, x to the 8th comes down, y to the 12th comes down. Then I'm going to bring down this 4xy cubed. Okay, so now we're multiplying bases. So we're going to use the product rule, right? But before we deal with the exponents in the product rule, we just have 16 times 4, right? So those are normal numbers, so we'll just do normal number things, right? We'll just multiply them. 16 times 4 is 64. Okay, so we don't add them, right? Those are just normal numbers, so we just multiply them like we normally would. So now here's where the exponents come in. We have x to the 8th times x. So remember there's an invisible 1 there with that x. So we're going to add the exponents. That's the product rule. So 8 plus 1 is 9. Okay, then we'll do the same thing with the y's. We have like bases here with the y's. So we're going to add those exponents. 12 plus 3 is 15. that's as far as we can go with that. Nothing else to simplify.